Okay, good morning friends. Today we start the new chapter of 12th, Introduction to Polymer Chemistry. We all of you heard the name polymer. सभी को पता है कि पॉलीमर क्या है और उसकी यूज क्या है. टुडे इन डे टू डे लाइफ, अपने लाइफ में हम बहुत सी चीज़ें पॉलीमर की यूज करते हैं. जैसे कि सुबह उठते ही हम ब्रश करते हैं, सो ब्रश इट मेड अप फ्रॉम पॉलीमर. बकेट, मग, डोरी, रस्सी, अपने कंबल, शर्ट, जो भी है, ज़्यादा से ज़्यादा हम चीज़ें पॉलीमर की यूज करते हैं. सो पॉलीमर it is obtained from nature also, and some polymer we made from synthetically. So that will be discussed on later on. So first introduction about the polymer chemistry. So polymer, it is the complex and giant molecule. Polymer, it is complex and giant molecule. Giant means it is very big molecule. So it is also called as the macro molecule. Macro means big molecule. So polymer, it is made up of from repeating unit of small molecule. Repeating unit of small molecule, it is called as the monomer. It is called as the monomer. So repeating unit, whenever the repeat unit are combined, it forms polymer. So the term polymer, it is originated from the Greek words poly. Poly meanings many and mer meanings unit or part. Whenever the many parts are combined, it forms polymer. So polymers, it is very high molecular mass, macromolecules. Again the word macromolecule. Macro means big molecule, and having its molecular mass, it is 10 raised to power 3 to 10 raised to power 7 unit. So this is very huge molecule, hence it is also called as the macromolecule. So for example polyethylene, अपन एक example लेंगे polyethylene. So polyethylene, it is made up from monomer ethene. So this is ethene. When ethene reacted with another ethene molecule, so it forms dimer. Whenever the two ethene molecule or two part of the monomer are mixed, it forms dimer. Then again addition of third part, it is trimer. Addition of fourth part, tetramer, pentamer, hexamer. Like this way, where n number of monomer unit added, and after polymerization, it forms polymer. So this is monomer, and after polymerization, it gives polymer. Here we take an example ethene. So ethene is converted into polyethylene. So this is all about the introduction of polymer chemistry. Classification of polymer. So polymer are classified into several ways or number of ways. So according to that, first classification is on the basis of source or origin. The source of the classification on the basis of source, the polymer are classified into three types. First one, natural polymer. Second one, synthetic polymer, and third one, it is semi-synthetic polymer. So natural, we discuss about the natural polymer. So natural polymer, which is obtained from natural sources. Which is obtained from natural sources. In nature, the two type of sources. First one, it is the plant, and another it is the animal. So plant, the polymer which obtained from the plant, it is called as the plant polymer. Example, cotton, linen and rubber. These are the example of plant polymer which is obtained from naturally. Then second example, the animal polymer. It is obtained from animal. The polymer which is obtained from animal, the example, it is wool and silk. We know very well about that, the wool and silk, we are using this. So these are the sources of animal polymer. Then second type, that is the synthetic polymer. So the polymer which is prepared artificially by polymerization process. The polymer which is prepared artificially by polymerization process is called as a synthetic polymer. So example of synthetic polymer, it is the nylon, terylene, synthetic rubber. These all made in laboratory processes or chemical processes. Then third type, semi-synthetic polymer. So natural polymer are modified by some chemical processes to increasing their strength, their uses, their flexibility. So natural polymer are modified by some chemical process is called as the semi-synthetic polymer. For example, cellulose acetate rayon, cellulose nitrate, copper ammonium rayon. Then another we generally known the terracotta. It is the made up from terylene and cotton. Terylene it is the synthetic polymer and cotton it is the natural polymer. Whenever these two are blended, it forms terracotta. So these all are the semi-synthetic polymer. Classification on the basis of structure. This is second type of classification. So on the basis of structure, the polymers are classified into three types. First one linear or straight chain, second branch, and third three-dimensional or cross-linked polymer. So first discuss on first linear or straight chain polymer. So linear or straight chain polymer, in this the monomer are joined together by linearly. The monomer are joined together by linearly from the linear or straight chain. So monomer unit are joined together in linearly. So this is the linear arrangement. So this type of polymer is called as the linear or straight chain polymer. So example polyethylene, PVC. So these are the example of linear or straight chain polymer. So here we also mention the polyethylene structure. So this CH2 CH2 unit are combined linearly to each other. So then second branch polymer. So the polymer chain which contain one main chain and another smaller branch chain polymer. So this type of polymer is called as a branch or branch chain structure. Example polypropylene LDPE. So this is the main chain and one is the branch chain. For this example polypropylene CH2 CH, here CH3 is the branch. So this type of the structure of polypropylene. Then third type of polymer, that is the three dimension or cross-link polymer. The polymer arrangement in cross-link or network or three dimension. Example is bakelite and melamine. So arrangement of network type. Here network type polymer chain. So bakelite it is used in electric buttons. So these are the example of three-dimensional or cross-link polymer. The third type of classification based on the polymerization process. So there are three type of process of polymerization. First one it is addition polymerization, condensation polymerization and ring opening polymerization. So polymerization means low molecular mass compound in presence of temperature and or in presence of pressure or in presence of catalyst, it converted into high molecular mass compound. So monomer, low molecular mass compound, it is the monomer. In polymerization process using of temperature, pressure or catalyst, so monomer is converted into polymer. So this process is called as the polymerization. So polymerization process are three types. Addition polymerization, which is also called as chain growth polymerization. Second it is condensation polymerization. It is also called as the step growth polymerization. And third it is the ring opening polymerization. We have discussed on first, that is the addition polymerization process. So addition polymerization, the formation of polymer by using addition of monomer. The formation of polymer by using addition of monomer without loss of small molecule. So in this addition polymerization process, monomer is added without loss of small molecule like water or methanol. So in this addition polymerization, compound containing double bonded. Generally monomer uses double bond monomer. So for example PVC, polyethylene, acrylonitrile, these are the example of addition polymerization. Here we discuss the example. So polyvinyl chloride, that is the PVC. So it will be made from the polymer monomer vinyl chloride. So here carbon carbon double bond, one chlorine molecule. After polymerization it is converted into polyvinyl chloride. So it is also called as the PVC. So addition polymerization carried out through free radical mechanism. Whatever this reaction, it is carried out by using free radical mechanism, and the free radical mechanism are broadly in three types or three steps. The free radical mechanism are done in three steps. First step it is chain initiation, second chain propagation, chain termination. We earlier discussed the addition polymerization and their mechanism. So addition polymerization and their mechanisms are processed in three steps. First step is chain initiation, second it is chain propagation, and third is chain termination. So chain initiation, initiation means initiate, to start the chain. So first we discuss now chain initiation, the chain reaction initiated by free radicals, and initiator, it is also called as the catalyst. So in chain initiator reaction, benzoyl peroxide or acetyl peroxide, these are the catalysts are used in this, used as a chain initiator. And this initiator which is used to produce the free radicals. You know the concept of free radicals. What is free radicals? The free radicals are the species which having one unpaired electron. So how it is generated we can see. So example here acetyl peroxide we take an example, and this peroxide bond of oxygen oxygen, peroxide bond of oxygen oxygen, it will be break by equal breaking of this peroxide bond. Equal breaking means each bond, suppose this oxygen and this oxygen, each bond consisted with 2 इलेक्ट्रॉन. आपको पता है कि एक बॉन्ड बनने के लिए कितने 2 इलेक्ट्रॉन्स की जरूरत होती है, तो ये एक बॉन्ड बनता है. तो whenever the breaking of bond, equal breaking of bond, one electron shifted to this oxygen, another electron shifted to this oxygen, and then generation of 2 free radicals. Generation of 2 oxygen free radicals. So here in this reaction we using acetyl peroxide. This acetyl peroxide equal breaking of bond, it's converted into negative charge here. Then after rearrangement, after loss of carbon dioxide, generation of methyl radical. So this is methyl free radicals, and this methyl free radical generally it is indicated as R group. This is R degree means free radicals. So these free radicals, example, these free radicals attack with the monomer. This free radical attack with the monomer which having double bonded carbon. This double bonded carbon again converted into new radicals. So here also breaking of equal breaking of double bond. One electron goes to this carbon, another electron goes to this carbon, and here generation of new free radicals. And this new free radical then goes to second step, that is the chain propagation. This chain propagation step, it is also called as the chain growth. So here the growth of the chain. This new free radical again react with n number of these monomer species, here growth of change occur, and at the terminal end there will be presence of one chain termination. Termination means a stop, to stop the chain reaction. So at the some stage of growing chain, the terminate or stop by the growing chain. The chain termination occur by using combining these two growing chain radicals are each other and stop the chain. Suppose this is first growing chain radical which are formed in chain initiation reaction. This is second growing chain radicals. So these radicals are come to each other and formation of bond, and after this coming the bond formation, the chain will be stopped. So here the polymerization process is stopped. So polymerization, complete polymerization process, addition polymerization process are carried out in three ways. First, chain initiation, chain propagation and chain termination. In chain initiation, start the chain growth, chain by using catalyst. Then second, chain propagation, initiate or growing the chain. In first step, start the chain, then growing the chain, and last stop the chain. So these are the three steps for the addition polymerization mechanism. So mechanism of polymerization carried out by using these three steps: initiation, chain propagation and chain termination. So here terminate means these two growing chain radicals are come to each other and form a polymer. So here these radicals are finish, and after finishing radicals the complete we got the polymer. Here the chain polymerization. This is all about the addition polymerization process. Then second type, condensation polymerization. First we discuss the addition polymerization, second it is condensation. The process of formation of polymerization from polyfunctional monomer with the loss of or elimination of small molecule like water, methanol, ammonia, HCl. This process is called as the condensation polymerization process. So means formation of polymer by using polyfunctional. Polyfunctional means which having more than one functional group. Polyfunctional monomer means more than one functional group monomer are reacted with elimination of small molecule. Whenever reaction of carried out, elimination of small molecule by like water, methanol, ammonia, HCl. So such polymerization is called as the condensation polymerization. So here taken we example formation of pteridine. So pteridine prepared by using ethylene glycol and terephthalic acid. So it is polyfunctional monomer. Ethylene glycol, it is polyfunctional monomer. Polyfunctional means it's having two functional group. So ethylene glycol having two OH group and terephthalic acid having two OH group. So after condensation, loss of water molecule, and here formation of pteridine. So here OH replaced from this glycol and H replaced from this acid, terephthalic acid. So loss of water molecule, here will be formation of pteridine or dacron. So here this linkage occur, oxygen, this linkage occur. This linkage is called as the ester linkage. So such type of polymer it is called as the polyester also. Such type of polymer it is called as the polyester. So during this condensation reaction are carried out by using step by step. So first monomer react with another, then second, then third, fourth, fifth, like this way. So this polymerization occurs step by step. Hence, condensation polymerization, it is also called as the step growth polymerization. Condensation polymerization is also called as the step growth polymerization because condensation occur in step by step. In first two molecular react, the loss of one water molecule, then second, third, like this way n number of molecules are reacted, and here loss of n number of water molecule, we got the polymer. So here ester linkage, hence it is called as the polyester, and the name of this compound it is pterylene, or it is another name, it is the dacron. So this is about the condensation polymerization. Then third type, ring opening polymerization. Ring opening polymerization. The cyclic compound like lactams, cyclic ether and lactones. So this cyclic compound polymerized by using ring opening polymerization. Ring opening means opening a ring. So these are cyclic compounds. So cyclic compound breaking the ring, hence this polymerization is called as a ring opening polymerization. So this polymerization requires strong acid or base catalyst. For example, polymerization of E-caprolactam. So polymerization of E-caprolactam. So this is lactam, cyclic lactam, which converted into nylon 6. So here E-caprolactam, which having 7 atom cyclic ring. So in this cyclic ring, 6 are carbon and 1 it is nitrogen. So after polymerization, this E-caprolactam is converted into nylon 6. So the number 6 is given because this polymerization in monomer unit, the presence of 6 carbon, 5 in CS2 and 1 in CO. So hence this is called as the nylon 6. So opening of ring. So when we use acid or base catalyst, breaking of this cycle from here, cyclic structure from here, and is converted into long chain polymerization. So this is nylon 6. So ring opening, it is very easy. Opening of cyclic ring. So here breaking of cyclic ring and converted into polymer. Here we use E-caprolactam, that is the E means eta position. So this is alpha carbon, beta, gamma, delta and eta. So this eta group attached to nitrogen. Hence it is called as the E-caprolactam. So this is converted into nylon 6. So this is 3 type of process of polymerization. First one, addition polymerization, condensation polymerization, and this is third, ring opening polymerization. Classification on the basis of intermolecular forces. So mechanical properties of the polymer, which is depend on mechanical properties of polymer such as tensile strength, toughness, elasticity, that all properties are depending on the intermolecular forces. So according to this classification, polymers are 4 types: elastomer, fiber, thermoplastic polymer and thermosetting polymer. So in first property, elastomer. Elastomer property, it is the elasticity. हमको पता है elasticity. Elastic means when we apply the force, external force, it stretch and release the force, it come back in its original position. जैसे भी elastic रबर, जैसे कि रबर उसको अगर खींचते हैं, फोर्स अप्लाई करते हैं, वो स्ट्रेच होता है, और फोर्स रिलीज करते हैं तब वो अपनी पर ओरिजिनल पोजीशन में आ जाता है. तो उसको कहते हैं इलास्टिक प्रॉपर्टी, एंड उस टाइप के पॉलीमर को कहते हैं इलास्टोमर्स. सो इन इलास्टोमर्स दे हैविंग वीक वंडरवाल फोर्सेस एंड few of cross-link between the chain. Some cross-link उसकी चेन में होते हैं. तो due to the weak van der Waals forces, they are stretched, and when we release the force, it come back because of the cross link present in their chain. So example for elastomers, vulcanized rubber, neoprene, Bunayan, Bunayas, these are the examples. So neoprene, it is the natural rubber, vulcanized rubber. So so these are the example of elastomer. Then second property, second classification, fibers. We know very well about that, the fiber. So they having very high tensile strength. फाइबर जैसे कि नायलॉन की डोरी है, रस्सी है, तो उसमें स्ट्रेंथ ज़्यादा रहती है. और फाइबर के जो मटेरियल है स्ट्रेच, फाइबर मटेरियल इट इज स्ट्रेच. सो इन फाइबर पॉलीमर, so it contain very strong intermolecular force. It contain very strong intermolecular force and strong dipole force. ये दो फोर्स होते हैं उसमें, इसलिए वो वेरी स्ट्रॉन्ग नायलॉन की रस्सी आपने देखी होंगी, आप खींच के देखो तो बहुत ही उसमें स्ट्रेंथ रहती है. सो बिकॉज क्योंकि इसमें वेरी स्ट्रॉन्ग इंटरमोलिकुलर फोर्स एंड स्ट्रॉन्ग डायपोल फोर्स. Then example of this fiber, polyamide, example nylon 66, terylene. Third type, thermoplastic polymer. Thermoplastic polymer, it is the remolded reused plastic. जो अपने डे टू डे लाइफ में अपने घर में बहुत से प्लास्टिक की चीज़ें होते हैं जिनको अपन रिसाइकल कर सकते हैं, रिमोल्ड कर सकते हैं और रीयूज कर सकते हैं. दिस टाइप ऑफ प्लास्टिक इट इज द थर्मोप्लास्टिक. एंड the speciality of this thermoplastic material, it is repeatedly softening on heating. जितना भी आप रिपीटेडली उनको हीट करो वो सॉफ्ट होते हैं. एंड हार्डनिंग ऑन कूलिंग, जैसे ही कूल करो वो हार्ड हो जाता है. ड्यू टू दिस प्रॉपर्टी वी कैन मेक चेंजेस इन देयर मोल्ड. वी कैन रीमोल्ड इट, रीयूज एंड रिसाइकल ऑफ दिस प्लास्टिक. एंड the force of intermolecular forces, moderately strong intermolecular forces are present in this thermoplastic polymer, and it is intermediate between elastomer and fiber. So elastomer having weak forces and fiber having strong forces. So moderately strong intermolecular forces are present in thermoplastic material. So example of thermoplastic material, polyethylene, polystyrene, polyvinylene. So PVC, polyethylene का यूज़ तो हम डेली करते हैं. डे टू डे लाइफ में कितनी चीज़ें पॉलीथिलीन की बनी रहती है, प्लस बॉटल्स, पेन्स, ये तो उनको अपन रिसाइकल कर सकते हैं, रिमोल्ड कर सकते हैं और रीयूज कर सकते हैं. देन फोर्थ, thermosetting polymers. So thermosetting polymers, whenever the softening on heating, but when he more heated, it is stable or hard. So it does not reuse. Once hardened, it cannot be soft. So this material thermosetting polymer, एक बार अगर वो सॉफ्ट हो गया और उसका मोल्ड बन गया, we cannot remold it, we cannot reuse, we cannot recycle this thermosetting polymer. It cannot be softened by heating and cannot be remolded because it contains extensive large number of cross-link polymer. Due to cross-link polymer, once they form, they cannot remold it. So large number of cross-link polymer by covalent bond. And example of this, bakelite, urea, formaldehyde. So bakelite used in electric switches, that is black button. We earlierly use black buttons, so that is the bakelite. Then cooker handles, which is bakelite material. Once it is set, it does not change or remold it. So these are the four type of classification on the basis of intermolecular forces. So fifth type of classification, it's based on monomer unit. Polymer having number of monomer unit. So it's having another two types. One, it is homomer and another is copolymer. So in homomer, the polymer contain only one monomer repeating unit. The polymer contain only one monomer repeating unit is called as the homomer. And copolymer, if two or more monomer unit repeating unit present in polymer, two or more monomer repeating unit present in polymer is called as the copolymer. Monomer examples nylon 6, nylon double 6, then polyethylene, PVC, so many examples. And copolymer, it contains two or more monomer unit. Bunion, bunious, these are the example of copolymer. Then classification is based on biodegradability. Biodegradability, they are again two types, non-biodegradable and biodegradable. Polymers are two types again, non-biodegradable and biodegradable. So synthetic polymers are non-biodegradable. It does not degrade easily in environment. So this called as the non-biodegradable. For example, polythene, PVC. So if they are dumped in soil, so number of years they are present as it is because they are non-biodegradable. And biodegradable materials, so when they are degraded by the environment or environmental bacteria or some environmental natural chemical reaction, so this is called as the biodegradable polymer. So natural polymers are generally biodegradable polymer. They are degrade easily. Suppose cotton, wool, they are degraded after some times. But synthetic polymer, they does not degrade. So these all are about the classification of polymers. We have are in our syllabus. So total 6 type of classification are present in our syllabus. Summary of the polymer classification. So polymer classification is on 6 type. First on source, natural, synthetic and semi-synthetic polymer. Second on nature, linear, branch and cross-link polymer. Then third, polymerization process, addition polymer, condensation polymer and ring opening polymer. Then the classification based on intermolecular forces, elastomer, fiber, thermoplastic and thermosetting polymer. And classification based on monomer unit, it's having homomer and copolymer. And last, 6 number, classification based on their biodegradability. The 2 type of polymer, non-biodegradable and biodegradable. These are overall summary of the introduction and classification of the polymer.